Hey everybody, this is Grant Sims, the Chief River Security. I just did a couple videos on OAuth for the enterprise and some high level, what are the issues we face and how can OAuth solve for some of these issues. Trying to take it a step down, I wanted to do a demonstration via a PoC where we can actually get to the technical bits and see how this works under the hood for both the authorization code flow, proof key exchange, as well as the client credential flow. I think those are the two main flows if you're looking to implement authorization, OAuth in your enterprise. I think those are the two most important flows to think about. One being the client credential flow, very simplistic flow, great place to start, and really shows you how you can centralize your service identities or your client credential identities and perform OAuth, as well as setting up an OIDC flow via the authorization code flow for your developers so that your services are interacting with your resources utilizing the client credential flow, and your developers of those services are interacting as themselves with those same resources using the authorization code flow. Those two in combination, I think, will set up your enterprise for success in centralizing your identities. So here you can check out Chief River at GitHub. The repo is Okta OAuth PoC. And I just wanted to walk a little bit through, what this is, what it contains, and then show you a demo of how it works. So the application really has three parts. It's got the Okta Terrform IAC infrastructure as code using Terrform. We have a test resource server and a test client. We'll also be using Postman as well as another client, the client for your authorization code flow for your developer use cases. So starting with Okta, this is all Terraform using the Okta provider. It'll set up 2 users. It'll set up 2 developer groups. So each one of those users will be part of one of those developer groups. So user 1's part of developer group 1, user 2's in the development group 2. We're going to set up 2 OpenID Connect applications for those dev user groups above, just to simulate, if you have 2 development groups, how you might authorize one for some resources and then authorize some for some other resources. We'll also set up 3 client applications. These will represent the microservices using the client credential flow. And we'll set up 2 authorization servers as well, which will have a mix of allowed clients. Once again, this is just so you can do some testing to see how one development group or one service may be able to get access tokens for from one authorization server but not the other, and vice versa. You can also configure the resource service to point at one of those authorization servers to test some of those different use case scenarios out as well. So Okta Terraform all out provides this kind of setup for you right out of the box. Resource server, that's the next component here. This will be the actual, it's a simple Node.js environment where basically it just takes a token from a GET request at the root level there, and as long as everything's valid, you'll get a 200 code back, and it'll also produce some of the information that was provided in that token, just so you can see kind of what's being passed around and what's being provided to a resource and how it's validating it. It also basically give you some PoC type of Node.js code to show you how you can validate JWT tokens that come in. We can change the audience value for this resource server, just once again testing out things within OAuth to see how different validations happen. One of those being validating the audience claim that comes in. And the last part will be the client. Corresponding kind of to the resource server, I have a test client that's set up Node.js. And basically what it does is, using the client credential flow, it kind of emulates, what a service might be in your environment to go and obtain tokens from the authorization server and then send those to the running resource server, once again, you can kind of see both sides, what the client sees and what the resource server sees. And you're able to get an idea of what a service might be able to do to obtain a token and then pass that token to a resource server to be validated. To get it set up, just some quick steps for each of these. Setting up Okta, you got to go get a developer account, sign up. You want to use the Workforce Identity Cloud free version. Once you get in there, go set up the only manual ClickOps thing you need to do is go get an API token set up. So go to the security, API section and create a token there that you'll provide to Terrform to be able to deploy the Okta infrastructure. Once there, typical Terraform init, Terraform apply, and then Terraform should output all the details you need straight to the console to do any type of configuration and testing of, your clients, your resource, or Postman. Due to some of the values being marked sensitive, just realize that you have to, run some additional commands to output those sensitive data elements when you're plugging them into those clients. To test the client credential flow here, like I said, we got the resource server, we got the client. At the end of the day, basically what we need to do is, make sure you have Node installed, install the dependencies, and then run the Node package there. There are some environment variables you'll need to set, such as your authorization server, which you'll get from your Terraform output, as well as if you want to, customize your audience value. Once again, just testing some scenarios there. Basically the same thing with the client. You need to make sure you have Node installed. You need to install all your dependencies, and then you need to set some environment variables such as your basic auth, which in the case of this client and the client credential flow, this basic authorization here is actually a base 64 of your client ID within Okta, then a colon, and then your client secret. You can see the colon right here. So basically, this is your client credential flow authentication to get a token from this authorization server and then send that to the resource server above. So the next kind of flow we had, so this is, like I said, client credential. The next flow we can also test is, acting as a developer who, is developing on this service. You really don't want them to possess these credentials in a true environment. These credentials here were intended for a service, not for humans to utilize. If we're passing these around, we haven't done us any justice. We've just actually, incurred more risk than we needed. So for developers, they need to be, interacting with this service and developing on it as themselves. They need to get their own access tokens. So to do this, we will be, using a tool like Postman to authenticate as us, user 1 or user 2, that's part of those development groups, and obtaining an access token, and then sending that same access token, just as we did in the client credential flow above, but as ourselves. And we can also, interrogate these tokens to see exactly what they contain, show that, it shows that, user 1 is actually obtaining this, token versus, above where it was a client or a system credential. And we'll be able to send that to the same, test resource server as well. And I just gave some things to think about, or some things to try and test as you get familiar with OAuth. Like changing to the other authorization server, looking at the allowed clients, seeing if your auth server policies are working correctly. Try changing the audience value to see if the resource server is actually validating the audience as it should per the spec. Try changing the scopes. Try sending an invalid JWT to a resource server. All these different things you can try and test, and it helps you get familiar with, like I said, the two main flows: client credential flow, authorization code flow, as well as how does JWT validation happen. So with that, let's transition over to the demo. So here I've logged into my dev account. As you can see, I don't have anything but the basic applications that are provided by default, I don't have any users but my main user here, my federated identity that's an admin. So now I need to go and get an access token, set that up. I've already done that, but if you need to go get an access token to allow Terrform to do the deployment, click on security, go to API, and come over here to tokens. I've already crafted a token. It'll present you a one-time secret. Load that secret as an environment variable into your Terraform terminal there so that Terraform can do its thing. So focusing back over here on the code, I've already cloned the repo. If we go look at the Okta directory here, this is where all of our infrastructure lives. If you go look at providers, I gave you basically the things you need to set as environment variables. So basically take these, change the environment variables to your environment, to what your dev instance of Okta is, as well as what your API token is. Don't worry guys, this API token has been invalidated. It's not accurate, and we're in a demo environment. But nonetheless, take those and load those into your terminal. So here we go. I have 3 terminals set up. I have an Okta deployment. We'll call this the deployment terminal. This is where I'm going to be running Terraform to produce my Okta infrastructure. This is the client where we're going to be running the test Node.js client, and this is the resource. We're going to be running the test resource, and I also have Postman set up here to run the user flows as well. So let's start with Terraform. So we got our environment variables already set, like I said. Now we need to deploy the Terraform. So if we look at the directory here, we are in the Okta Auth PoC in the Okta Terraform. This is where all of our resources live. We're going to deploy it. So I've already initialized this environment, but if you haven't yet, you would Terraform init it, and now we're just going to Terraform deploy. Terraform apply. I'm sorry, I do that all the time. Let's see what happens here. So it says we are going to create, scroll up here. Let's see. Terraform will apply the following actions. As you can see, it's going to create a handful of Terraform resources here. We scroll all the way to the bottom. It's going to add 31 resources, and it's going to apply these outputs. So we will say yes to deploy those objects. Now Terraform is going out. It's reaching out to our Okta environment, our dev environment, using those environment variables that we set via the provider, and it's creating everything. So if we switch over to Okta right now, as this is being created, we can go over to the UI and also see what's going on over there. So let's go to the directory. Let's see people now. All right, you can see we've now got a user 1 created and a user 2 created. We've got some groups in here. We've got a developer group 1. We've got a developer group 2 that was created. We now have some applications. We have a resource developers group and 3 microservices. It looks like we're still waiting on the other resource developer OIDC application to come in. We'll come back to that here in a second. And then from a security perspective, if we go down to APIs, we can see that we have 2 authorization servers created. Within those, we can now get our authorization server endpoints. We can see scopes were created. With our Terraform, we created a custom access scope as well as an employee info scope. With those, we've also created a custom claim which will inject the user's employee number in case we need that on the resource server for whatever reason. Maybe the subclaim or the email address isn't enough, so instead we need the employee number. This is an example of how we can inject a user attribute into an access token. We've also got our, it looks like we're still waiting on some access policies to be created. Let's give it a second. Let's go check on our Terraform. All right, Terraform still being deployed. I find this to be the case with the developer instances of Okta. They run a little slow. I think they're rate limited. But nonetheless, we still got some resources being created. So let's give that a second. Let's jump back to our applications. Now you can see we have 5 applications. Both of our OIDC apps are now created, and our 3 microservice credentials, or I'll say client credential apps. Let's go back down to APIs. Let's go back with our authorization server, see if these are done yet. Still no access policies. Let's try the other one. Access policies. Looks like we're starting to create the access policies in here now. So you can see that for the authorization, authorizer for resource 2, we allow the developer group 2, service C, and service B. You'll notice that service A is not allowed to interact with this resource server, nor is the resource developers from group 1. Conversely, we can go back and hopefully resource 1 is done now. And we can see that only resource developers 1 are able to interact with this resource, authorization server for resource 1. Service A and service B, we have no resource developer group 2, nor service C can interact with this resource. So that's part of the testing you can do to, kind of make sure that works. Make sure that if service C is trying to get a token from authorization server 1, that is not allowed to, because it's not a part of the allowed groups. You can also go into each one of these rules, see what we've allowed. We've allowed the client credential flow as well as the authorization code flow. The tokens are going to live for 5 minutes. So during your testing, realize that if you get any of these access tokens and you want to use them against that test resource, that they're only going to be valid for 5 minutes. All right, so now that we got all of our infrastructure deployed, and we've checked everything out in the UI. We've got a good understanding of it. Let's go back here to our things, and we can see that Terrform is done doing its thing and deploying our Okta resources. Inside of here, we have all the outputs that you could have gained from the UI there, but just for ease of implementation, I wanted to provide them all here. So here's all your auth server 1 details. The custom auth scope that we provided, the custom OID scope that we set, the description of it, the issuer, the name, the well-known endpoint. Same for authorization server 2. Here's our clients, the dev group 1 client. This is the OIDC client for the developer group 1, which has its callback that we'll need to set up in Postman, its client ID, its secret. Same for the dev 2 group, and then all of the system to system or machine to machine client credential identities are here with their client ID and secret. And last but not least, our users, their username and their password that once again we'll need to use in Postman to perform the authorization code flow. So now that we have all this information, let's do some testing. First of all, just to call out, if you're not familiar with authorization servers, know that this is an endpoint that is typically public, that you can gain any information you need to know about that authorization server. If these outputs weren't provided here and you were configuring an authorization server for a resource that knows how to work with well-known endpoints, this is typically the URL you'd be using. So just for example, we can come over here, I can paste this well-known endpoint into the browser, and it's going to tell me everything I need to know as a resource or someone configuring a resource, what this authorization server is about, where it's, who's the issuer, what is the authorization endpoint, what is the token endpoint, the JWT SURI. This is where all of your public keys are stored so that you can locally validate tokens, which is very important to resources as well. And then much more information, supported, different scopes, supported claims, etc., etc. So very common endpoint. It's good to get familiar with these as you're commonly using these when setting up resources. Our resource, though, it's a simple test Node.js resource. It is just going to be using, manual configured items from this to set that up. So back to the demo. All right, our Terraform is deployed. We no longer really need this other than to pull out environment variables. So let's go over here and look at the README, and let's set up our resource and get this test going. So let's set up the resource server. So we already CD'd into the resource. We've already done our npm install. Basically, we need to set our environment variable. So similar to this one, we need to set up our auth server. So we'll take this auth server. We'll come back over to our authorization. Remember, this is our resource server, which we're setting up right now. We want to configure our auth server, and let's use auth server 1 for this example. So we'll take our issuer here, and we'll copy that, and we'll paste that in. And now we have our auth server set. And what other environment variables? Our audience, okay? Audience equals resource 1. Let's take this. And if we look over here, that is the default audience that we have set here. You can see audience is set to resource 1 as part of the Terraform. So we're just going to set up, and I see I messed up there above. I never actually set the environment variable. I just did this. So let's say export. All right, so now we got both of our auth server and audience environment variables set. So if we come back over here, now we just need to run the resource. So let's just run it. We're good to go. Let's do node index.js. All right, you can see our service is running. It's on HTTP localhost. All right, the resource is sitting there. It's pointing at our authorization server. It's got the audience value set for what it's going to validate. Now we need to send tokens to it and see what happens. So let's set up our client over here. Let's do the client credential flow first. This is the most simplistic one. You know, being very generic here. This service, this Node.js code is going to use a client ID and secret, which is an client application set up in Okta. It's going to authenticate with Okta. It's then going to call the token endpoint to get a token with that authentication. It's going to receive a short-term JWT token, and then it's going to send it over to this resource here on the right side running at localhost 3000. Let's give it a shot and see what happens. So to run this, we need to set up a couple more environment variables. So first one, we need to set up the auth server. We need to know where this client needs to go get tokens. So very similar to over here, we can just grab this same auth server, paste it over here. So we have our auth server set. Now we need to set our client credentials for this client credential flow to authenticate. So coming back down here, you can see that let's use service A here. So like I said before, these are deemed sensitive variables, so we have to actually output them. So we'll say Terraform output, and let's do service A secret. Here's our secret. So now we need to combine those as part of our basic auth. So we need our client ID for service A. We need a colon, and then we need the secret. These are already base 64'd for you, so no need to worry about that. So now we have this. We can copy that, and now we need to set our environment variable for it. So once again, I can see I messed up over here. Did not actually set that. All right, now we need to export. And what was the environment variable again? Let's paste this in just so we don't lose it. And the environment variable is basic auth. Let's copy that. Come back over here. And let's set this environment variable. Basic auth. All right, we should have everything according to the README that needs to be set. Now we need to run the client. So directory, let's cd to test client, and let's run it. All right, it says it's getting a token. It acquired a token. So it was able to authenticate correctly. It got a token. It made a call to localhost over here. You can see that we got a response code 200. And then the response data from our server over here is very basic. It's just saying that the token was valid. This is the response. Is the token valid? Yes. Here is the claims within the token. You can see here's our issuer. Here is our expiration time and when the token was crafted or created. You will see that if you these are epoch times. If you turn them in, you will see that that is a 5-minute token. The audience set was resource 1. We had a scope that we requested of access, and the sub right here is the identifier of who accessed. This is actually the client. If you notice, if we come up here to service a client ID, this is the same value as in the subclaim. Now, what this client is going to do is every 60 seconds, it's going to try and call it again. We've already got a token, so it's able to get another one. It's just using that same token over and over again. As you can see on the right side here, we're also seeing the same information. The resource server is getting this token. It's locally validating that token via the configured, well-known endpoint URL of this authorization server. And if it's valid, it's spitting back out the information it sees within the token. I'm going to sit here and let this run for a little bit. It's going to run for 5 minutes. You'll then see this client fail on the left side because the token is no longer valid after 5 minutes. It'll then do a retry by going and getting a new access token and then continuing to use that token. So this will sit in an infinite loop. It'll get a token. That token will be valid for 5 minutes, sending it every 60 seconds to the resource server. Then the token will become invalid because they only live for 5 minutes. The client will then notice that that token's no longer valid, no longer working, go try to obtain a new token, and then continue over and over again. So this just gets you an idea of how a client can sit there, reuse a token. When it fails, go get a new token, and then once again start interacting with the authorization server. So I'll sit here and pause. I'll speed this part of the video up, and you can see it work in action here. All right, as you can see here, we ended up failing out on the API call. The token failed. It went and the client went and got a new token. It acquired a new token. It started calling it again. As you can see, we now have a new token because the issuing times and the expiration times are different. On the server side, you can see that we got a failed attempt because the JWT did time out after 5 minutes. However, through retry, the client over here went back out, got another token, and started proceeding through here. So we can see that tokens are timing out after 5 minutes. If they fail, the client can then perform the client credential again, client credential flow, and go get a new token and proceed to talking. Now, let's test some different things as far as OAuth validation. So maybe we could test, let's see, the audience value is set to resource 1. Let's change the audience value. Let's change the audience to say resource 2. So now this server, this resource over here, resource server, is expecting an audience value of 2. When the client over here goes out and gets a token, it's going to get a token from the authorization server that has an audience value set of 1. So let's make sure that this fails. So we're going to set it up. You can see the server is running. It's looking for an audience value of resource 2. We're going to run this. It goes out, it gets a token, it acquires it, it calls it. But it failed. Token invalid. The audience claim resource 1 does not match the expected audience resource 2. So you can see here we're providing it a incorrect resource here of 2, and it's expecting the resource 1. So that was a quick check we could do right there. Let's set that back to audience 1. Let's change the client ID. Remember that we're over here, we're working with authorization server 1, which is valid for clients A and B. Let's change to client C over here and see what we get. So go back up here. Let's output services C secret and change this. So now we have authorized C here. Let's change our basic auth. Remember that the code inside here is actually taking this client ID : client secret and base 64ing it for us for the request. So let's copy and paste client C right here. This is the ID. Paste that in, then a colon, then the secret for client C. Let's paste this in. All right, so now if we run this, we're going to be acting as, or I should say authenticating as client C. Let's run this. So it's trying to get a token. Up, denied. Access is denied. Policy evaluation failed. If we go back over here and we look at our authorization server 1, you can clearly see here in the access policies that we have not allowed service C to integrate. You can also go down here to the system logs, and if we refresh this, you can see that client C failed to get a token because there's no matching policy. Now client C is authorized to talk with resource server 2. So let's get that test going. First of all, let's change our client to point to the correct now auth server for auth server 2. So we're going to take this issuer right here. We're going to copy this. This is from auth server 2. Let's delete this. So auth server 2 now. And let's change it on this side as well. Oh, I didn't correctly set that. Let's do export. So now we have auth server 2 configured on our client. Let's configure our resource for the same. Remember that the authorizer authorizer server 2 is looking for an audience of resource 2. So now we have to change that. So let's change that to match. All right, so now we're set up for the client is client service C or client ID C, and we're authenticating as that. We're trying to get a token from authorization server 2, which we should have a policy for, and our resource over here is pointing at authorization server 2 for validation. So let's run this. We can see that we're pointing at authorization server 2 with an audience resource of 2, and now we're going to run this. So token acquired. Everything's working again. Like I said, pointing at authorization server 2. This is our client ID for our service C over here, and we've updated the necessary things. So you can sit here and play around, change authorization servers, change client IDs, etc., and that way you can test the different functionalities and validations of OAuth. Next, what we're going to do is look at it from a developer's perspective. Let's configure and test the flow and a GET request to this test resource, but acting as a developer. We don't want to give these credentials over here for an intended client or a service, a machine-to-machine application to a developer. We want them to interact with this service over here, this resource, as themselves. So we'll stop this client authentication. Remember now, we're set up as the resource server 2 over here. So let's get our client, in this case Postman, a developer using Postman, set up to interact, get a token from this authorization server 2, and get a token and perform a GET request. Now if we go back over here and we look at authorization server 2, let's see who's allowed to interact with this. We've already tested service C. Now we want to test resource developer group 2. So if we go look at those groups over here, let's go look at the groups, resource development 2 group. We have user 2 is in there. If we actually go look at the application that we were looking at, resource developers 2, we can go see the members of this. So if we go look at the assignment, we go look at groups, the developer group 2 is part of this resource developers 2 that we saw in the access policy, and who is within this group is user 2. So we want to test with user 2 to get a successful connection. So let's pull up Postman and let's configure our authentication. We want to do, let me clear this out real quick. Clear. We want to set up OAuth 2. We need to set up the following things to perform the authorization code flow PKCE. So we'll make the token. Let's just clear tokens in case we already had some in here. Let's clear cookies. Let's available tokens. Let's just clear these tokens. All right, they're all expired anyways. All right, so token. We're going to have a token named demo. We're going to perform authorization code flow. Callback URL. We can get that, and that's part of our Terrform output. So if we go to auth server 2, you can see here that, I'm sorry, not auth server 2, but if you go to the dev group 2 callback, this is the client application, we need to copy and paste this in. So we'll come over here, we'll copy the callback URL in. We need the authorization URL. All of this information can be obtained from the well-known endpoint. So make sure you're looking at auth server 2 here. Copy the well-known endpoint. Pull that up in your favorite browser. And here's all the information we need. So we needed the authorization endpoint, so let's copy that. Pasted that in. We need the access token URL, so let's go to the token endpoint here. We've got the token URL. Now we need the client ID and secret for the developer group 2 application. So let's go to the developer group 2, dev group 2 client ID. There's our client ID. Let's paste that in. Now we need the client secret. Let's go back over here, and because it's a deemed a secret value, we need to output it manually. Form output, and then let's go dev group 2 secret. All right, there's our secret value. Let's grab that. All right, we've got that pasted in there. Don't need to worry about this. Our scopes. These 3 are typical OpenID Connect scopes that are predefined. However, I added these 2. These are the 2 custom scopes we configured via our authorization server via our Terraform code. One is access. This is just the required scope to get an access token. And the employee info is a custom OIDC scope, which is actually injecting employee info into the access token. This will put in the department name as well as the employee ID number directly from our Okta directory to show you how you can inject information into an access token that is passed to a resource in case the resource needs to do something with that information. Maybe it needs to, make some type of insert into a database with the employee ID, or maybe it needs to, input something into a database based on their department. So this way, we can send information in an access token to a resource and have it validate that information, ensure that it is true and valid information without making any additional network calls or lookups to get this. We set the state, I just set it as all A's, and then you have to remember to change this to send the client credentials in the body per the Okta specs. So now that we have this all set, we're going to ask for an access token. It's going to ask us to sign in. Remember, we're signing in as developer 2, so we got to come back over here and get our user 2, I should say, information for logging in. So here's our username, and then we need the password. Once again, it is a deemed a secret variable, so we need to ask Terrform to output it for it. User to password. And there's our password. We will copy this. We will paste it in to the browser here. This is going to perform the authorization code flow to get a token for us. We got a token. Everything looks good. You'll notice, due to the scopes we were provided an access token as well as an ID token. We can now take this access token, copy it, and we can now take it and paste it into this GET request. We're going to change the authorization over here since we already got our token. We're going to change this to bear token. We're going to paste our token value in there, and we're going to send a request to localhost 300. Let's go back over here just before I do that and see how this is looking. Let's close this out. Let's clear it. Let's run it again. All right. And let's post this request. And as you see, we got a 200. We got our information back, which basically just returns the claims that was in the token that was sent. You can see that due to our scope of access and employee info, we did actually inject the department and the employee number into the token. We can also just take this token that we copied over here, and we can take it over to JWT.io, and we can paste this in and see the same information. This is just a JWT token, and here is the same information that was returned via our resource server earlier. One other validation we could do, or just I'll say interrogation, is going back to our tokens. Let's go back to our OAuth tokens. We can also, let's go look at our available tokens here. Manage tokens. Let's go look at the ID token. So once again, remember we selected those OIDC scopes. Similar to an access token, but this is meant for the client. This isn't meant to send to a resource, so that's why we're sending our access tokens to the resource server, not the ID token. But you can see that how a client could use this. If our client needed information as far as, our name, our email address, it could even have a profile picture, how we authenticated, where we authenticated, what time we authenticated, etc. You can add more information, but these tokens are intended for the client. In our use case, we didn't really have a use case for this, but in some type of application, client application, single page application, you might want to use this information, one, to authenticate the user, and then to display maybe their profile picture and their name. So anyways, within 5 minutes, this request will no longer work because the token will be invalidated, but wanted to show you how, as a developer, we can interact with the same authorization servers using our personal credentials, our developer credentials, to gain that access token and then send it to the resource server, just as we did with the machine-to-machine or client credential flow. So I hope this gave you a good idea of how to use a client credential flow for your systems and services, machine-to-machine calls, as well as how a developer can obtain those same tokens, but as themselves, and clearly identifying themselves in their tokens, so that should you need to do analytics or need some type of attribution, you can see who and when is interacting with your resource. If you have any questions, comments, or anything that you would like me to deep dive in, please feel free to reach out, and thank you very much. Have a good day.